Good evening, welcome to the Saturday evening update on the tropics here. As always, these thoughts are mine alone and making decisions regarding Tropical Storm Marco and Tropical Storm Laura. Please refer to the National Hurricane Center, your local weather office, and your local officials. So we're going to start with Marco here. This is further to the west, and so we'll get into Laura here in a minute. A little more complicated of a setup for Laura. But we're going to get into Marco first, as this has changed rather drastically today. If you remember, the forecast track had it near this area, and as you can see, it is not. The circulation is far to the north and east of where it was supposed to be. If we look at the shortwave imagery here of Marco, you can tell a couple of things here. One, the system is very, very small. We're going to wait for that to get there. And the core has been tiny almost all day, and so with smaller storms, you tend to have a higher tendency for fluctuation in the overall intensity of the system. Like today, it was making a run at hurricane this morning, and then it temporarily lost that inner core, and so it weakened a little bit, and now recon went back in and found around the same intensity it was at this morning because it had reorganized just a little bit. It doesn't take a whole lot to get these going in one direction or the other. So that's just a couple things to note here. So when talking about the impacts of the environment around it, you can just multiply the effects of what would normally happen with a normal sized storm and by twofold. Okay, so a couple things you can note here. If you look at the to the immediate west of the system, you can see these cloud tops are getting shaved off to the north and east. And so one thing to note is this is importing a lot of dry air. If you go to the COD meteorology satellite page, you can see all this dry air and the yellows and oranges off to the west of the system due to this trough that is now is kind of dragging Marco northward. And so this will be importing dry air and temporarily disrupting the circulation pretty much all the way up until it makes landfall somewhere along the central Gulf Coast in here. So what needs to be watched is how strong this is able to maintain itself at, and because that will ultimately determine where exactly this makes landfall. So a weaker storm, if you remember we were talking about yesterday, goes further to the west, and a stronger storm goes further to the north. So what we're watching here, if we look at the HWRF model run for Marco, you can see this is where it is currently at right now. You have a well-defined inner core, and this initializes the overall core structure pretty well. You can see just how tiny this is. It's a very small pressure gradient, and the storm is, very small. But as soon as it enters the Gulf, you can see all this dry air just off to the immediate west of the system getting pushed in to the system here due to shear, and you can see that the inner core struggles to maintain itself, and so it would be harder for the storm to remain stacked if the inner core continues to get shaved off. And so you can see the HWRF jogs a little bit to the west because the circulation is more surface weighted than mid-level weighted. So essentially you would have because the mid-level flow is more out of the south, and the surface level flow is more out of the south and east. And so that would mean that the storm would turn a little bit more to the west. As you can see here, the HWRF does this, turns a little bit more to the northwest here, and then it tries to re-intensify a little bit. You can see another burst of convection near the center, and this doesn't really get much stronger than where it's at right now. You can see this actually weakens pretty considerably here, and you have a surface low in here that is almost completely exposed because the mid-level flow, as you can see, is well removed to the north. And this is because of the southerly shear that is blowing into the system. You can see all these wind barbs. You have the surface flow, which is cyclonic here, but you have all these wind barbs out of the south and west here with plenty of dry air being pushed into the system, which moves the mid-level circulation to the north. And so we're going to be watching to see, how greatly affected this storm is by the shear, if it's able to maintain itself or if it's not. But on this particular H-Wharf run, you can see that it does not, and so you have the main surface low. Don't be fooled by this sudden movement of the lowest pressure. The main surface low is to the south and is decaying, and then you have the mid-level low in here, and it's going to want, I mean, this is likely the result of a center reformation due to prolonged lack of convection in the surface low here, but that's a very specific mesoscale feature that may not happen. So here's the original surface low that the H-Wharf has, and this is possibly a center reformation that occurs with the H-Wharf. Again, this is a mesoscale feature, so it's really hard to predict well in advance here, but you can see the H-Wharf moves this into the central Gulf Coast pretty quickly here, and we have it by 2 days out. The storm is practically on shore here and is getting ripped to pieces by this trough. It's not very strong, but again, the National Hurricane Center is kind of just a mean of the overall intensity forecast and guidance, so that's why hurricane watches are up for the central Gulf Coast from central Louisiana, the central Louisiana coast, all the way to extreme west Alabama coastline. And really, this may be a warm-up for what is to come here. But overall, just kind of keep watching Marco, make preparations for this, and you may have to keep them up depending on what Laura ends up doing. But we'll get to that in a second. All right, so let's get into Laura. So here's Laura. This is not getting any easier to forecast here. We have Laura's mid-level circulation has been moving all day and has been producing little kind of bits of surface circulation here. But the overall wave envelope is still very broad. You can see the flow still pretty large, and you have kind of vorticities showing up in the overall convective presentation of the system. So if you have like a big burst of convection, you'll have a mid-level center that may mix down temporarily to the lower levels and may temporarily take over the circulation, but overall it's still embedded within this large envelope of generally cyclonic flow here, and this is going to be generally advancing off to the west-northwest. And so what we're really watching here is for where an actual like bona fide center really takes over here, where it is able to go. And one of the features that may actually help this or impede this is obviously the mountains of Hispaniola, which are on the southern 2/3 of the island here. And this Laura will be passing directly over this practically. The overall envelope, that is. Maybe not the specific center of circulation, but the overall envelope will likely be passing over this. And so you may have a removal, which has been, ongoing for the past couple of days, a removal of the mid-level circulation here and the lower level center of the circulation here. And this has been largely in response to what is now relaxing southerly shear that has been pressing on the system and preventing the lower level circulation from really coupling well with the mid-level circulation. And so models today have been a little more favorable, wrong one, towards some development here. The GFS particularly has been significantly more a fan of this overall development here. So we're going to go to where it initializes right now. You can see this overall kind of axis here, and you can see, actually I'm going to line this out, the surface axis of the wave versus the mid-level flow of the wave, which is a little, to the south. And so as this continues on, GFS continues to keep the mid-level center somewhere down in southern Hispaniola and the surface low to the north of that. But it keeps a surface low intact. That's different than how the GFS has evolved in the past. GFS, kind of just kept this as an open wave here, passing west-northwest. And so GFS does have it a little stronger here. And GFS, as a result of it being, a little further to the north, actually keeps this north of Cuba or just on shore of Cuba here. And you can see that it doesn't really get too strong while it's north of Cuba, but it is present and you have a better organized system here. You can see this very well. You have the mid-level circulation here, just barely removed to the south and east of the system, and then you have the main lower level circulation just to the northwest of the mid-level circulation. And so this continues to kind of be decoupled temporarily here, but it enters the Gulf as a mid-grade tropical storm in here. And this is bad because if we look at the GFS models at the time of entry here, and keep in mind, I'm going to discuss this more later, but the point of entry here for the GFS and for many models and for LoRa in general is extremely important as to where this ends up along, the northwestern Gulf Coast, because if it's further south, then that means it's heading more towards Texas. It's further north, it's heading more towards Louisiana and maybe Mississippi. We'll talk about that in a minute, though. And so if you see this, you can look at this upper level environment, which favors, incredible outflow to the south and to the north of the system here. And so there's really light shear in this area. This is extremely light shear and a very divergent flow, which allows for convection to continue to roar in this area. And also the Gulf is extremely warm. If you look at the sea surface temperatures in here, this is almost entirely above 30 degrees Celsius within this region of the Gulf of Mexico. So really not a whole lot in this thing's way. There's not a lot of dry air, and there's not a lot of dry air being pushed into the system. This is in a far more favorable environment at this point than Marco would be in if it was moving through. And Marco really kind of gets out of the way here pretty quickly. And so the exact placement of the storm is very pertinent to the mid-level ridging pattern that would be guiding it generally off to the northwest, because you want, I'm going to illustrate this better on the GFS, or the European model upper dynamics here. I'm going to go ahead and get this up. So you have this ridge that's building off to the immediate north and east of the system. So the Euro has this north. Euro also has a strengthening hurricane in here. The Euro has this north here. And so that would mean that it would generally turn tighter with the overall structure of the ridge. Now, there are some models that have this further to the south, and further to the south is still a possibility. This is not, the models aren't just generally swaying towards one direction and that's going to be it. That's not the case, because, we're talking about a 50, 60 mile difference in here as to the point of entry here. And I actually calculated this on some of the runs, and the HMON, which brings it into just north of Galveston here, is only 40 miles to the south and west of the H-Wharf model, which brings it into central Louisiana. And this is a 200, let's just see how much of a difference this is. It's almost a 156 mile difference between the track here. And so this is because if the storm is a little further to the south, then the ridge, the overall flow is generally going to just turn it more to the northwest or to the west-northwest, and it's going to be more gradual of a turn here than, if it was closer to the ridge and it would turn more sharply. So very difficult angle to forecast. Again, this is still, 72 hours out before this even enters the Gulf of Mexico. So this is going to change a lot, and you're going to see track forecasts that range anywhere from, the central Gulf Coast to the Texas Gulf Coast here. For example, the HMON model at lunchtime had this actually going all the way into Texas here. But again, this is largely due to the mid-level feature here of this ridge that is to the immediate north and east of the system. And so this almost guarantees that the storm will be generally heading towards somewhere along the western two-thirds of the Gulf Coast. So if you're on the Gulf Coast and you're preparing for Marco, don't, let up your preparations just yet, because LoRa is probably going to be there within a couple of days of Marco. You can actually see Marco's mid-level presence here in southwestern Louisiana, and you have LoRa approaching the coast here around that same time frame. So Marco is still affecting these areas as LoRa is approaching. So And let's just kind of demonstrate this. You have a lot of tropical storm warnings here for the entire Caribbean now, essentially. You have tropical storm watches for Cuba in the western half of Cuba here. Those will probably turn into warnings. You also have tropical storm watches for the Keys and the southern Bahamas, including Andros Island and Long Island here. And one thing to note is, how the cone is, it encompasses the islands, and this is kind of just an average. This track is kind of an average of, the overall guidance here of where it may wiggle a little bit. And you can tell the overall track currently has this, turning sharper to the north. And really, I'm gonna show you guys now the H-Wharf model run here. So the H-Wharf model has this over central Cuba here. Keep in mind there's mountains just to the south here. And so as a result, since it does not pass directly over the mountains of Cuba, the storm circulation is able to maintain to be a little tighter here and is a little further to the north of the HMON model run. And HMON, don't discredit it just because sometimes it has, insane runs here. It still has been credible. It nailed Isaias earlier this year, and it has had a lot of upgrades, so it is more credible of a model than recent times, or than in the past. And so H-Wharf takes this off of the Cuban coast before it runs into any real mountains here, because the mountains are mostly to the south of where this tracks. And so it maintains this tight circulation, and it is able to quickly organize here. The H-Wharf has a deepening hurricane approaching the Gulf Coast here. This is a pretty strong hurricane here, and you can tell that the mid-level circulation is able to rapidly stack with the lower-level circulation here in due time. However, in the HMON model run, there's about and again, this is a tiny, tiny difference between the H-Wharf and the HMON. There's about an 18-mile difference in position around the same time that I just started the H-Wharf model run at. And so this runs over the mountains of Cuba and actually broadens the circulation a little bit. You have this broad surface circulation removed ever so slightly from the mid-level circulation immediately to the south of the surface circulation. And so, as a result, the storm is able to track more over Cuba and more west of northwest rather than, a little further to the north-northwest or to the west-northwest here. Just tiny, tiny, tiny track details here. And so, as this emerges from Cuba, you have a broader surface circulation in here, and you have a broad mid-level circulation here within the overall envelope of the surface circulation, but it's a little removed, and so it takes longer on the HMON for the storm to strengthen. You still have a hurricane here, but it does take a little bit longer to organize and, intensify here, and it still has a little bit of trouble here. And so we're talking about an 18-mile difference in track, making this much of a difference in the overall track and not only that, intensity of the storm, which would lead to, again, what I mentioned earlier, a nearly 160-mile difference in landfall point. So, again, we have several days to continue to look at this. This is still going to be tracking through Hispaniola and Cuba. But how the state of this and the position of this as it exits Cuba and as it enters the Gulf of Mexico is extremely crucial to how this overall evolves in the Gulf of Mexico, because if it is able to be further north, it would likely be a little stronger and a little faster to intensify, and if it's a little further to the south, then it would be more likely to not intensify as quickly. However, it likely would eventually undergo quick intensification given the more time that it has over water. But that is yet to be seen. And really, most of the answers that we will need will probably arrive somewhere on Monday afternoon at this point, where exactly the storm is at this time at 2 p.m. Monday. That's all for now. Please stay safe, and thanks for watching.